Hello there, this is Selim, a full stack developer passionate in building scalable and secure applications. Today, I am happy to share with you a demonstration of intimacy. So, during the demonstration, I'm going to go through the mission statement of the application, key process for both primary process and secondary process, and finally, system file overview. First, the mission statement. Intimacy is a dating application allows people to connect with each other. It's designed and built to be fast, secure, and easy to use. It runs on web browser, iOS, and Android devices. In the part of primary process, I will walk you through toggle application language, create and update user profiles, browse the application, browse other users' profiles, send and accept match requests, view matches, start real-time conversation, and finally, show the messages are end-to-end encrypted. Secondary process. In this part of the demo, I'm going to go through the testing strategy, the CI/CD pipeline, the monitoring system that allows me to monitor the health of my application, the logging system, and the alert system that allows me to receive alerts in real time. So in this part of the demo, I will present you the user experience across this application. So this application built using Angular and Ionic for the front end and Node.js with NestJS for the backend. So let's present this application. Here we are. So this is the landing page of the application. And now let's start by changing language. So here we can change language from English to French and from French to English. We start by creating an account. If it is an account, give it an email. Password. Putting password and sign up. Let's complete the profile. So now the application is smartly asking us to confirm that we are okay to allow the application to pick up our current location. I say yes while I'm using this application. Give it a name. I am a woman, my gender. I'm interested in women. Pick some images. Also, the application smartly asks us to give it a permission to access our library. So giving it full access. And it's asking also the permission to use the camera of your device. I allow that. Now I can use the library to choose images from there. Now time to create the account. Here we are. We can browse the application here for discovery, to discover profiles, here for messages, here for matches, and here is the host profile. So in the host profile we can change, for example, I'm looking for friendships, my age, the age range that I want could be like this or whatever I want. And here in profile I can preview my profile and I can update as well my information. So here, for example, I can say hello, this is Selim from Lille, France. You can see it here. I can also change my current location. So let's say I'm from here, from Prague. Sexual orientation, say I'm straight. Children, let's say I don't have one. And height, let's give it a height. Let's say this is my height. And With that said, now it's time to bring up a new account to match them. So here we can create a new account, give it an email, just keep it the same email, give it a password, and sign up. So again, we need to allow us access to our current location. So here, let's give a birthday, give it a name, Pauline, gender, woman, interested in men, some photos for the profile. I'll create the account. So here, Pauline, she can go here to discover. Now she can see this profile we created here for Salim. She can walk around, view the profile. She can see the current distance between these two accounts. And click to preview my profile. Salim from Lille, looking for friendship, straight, extra. Here, Salim also can see the profile of Pauline and can play with the card as he wants. Can view her information. So with that said, now it's time to send match. Pauline, she sent a match, and Salim, he sent a match. Now they are matched. Now it's time to send a message. So keep swiping, and here in matches page, in the both account, we can see they are presented here. Now it's time to send a message. Just before sending message, let's see my database. So as you can see, my database now is clean. There are no messages. And later, once we send message, we come back here to check for the new messages. So we're back again here to send message. Hello, Pauline. Nice to meet you. Where are you from? Now Pauline, she can answer if she wants. Hello, Salim. Nice to meet you too. I am from Lille, France. Now Pauline, now she can leave if she want. Let's say she left. And if you notice here, before it was green, now it's red, tell us she is offline. Still, we can preview her account from the message page. Now let's check for messages. Here in my database, you can see messages. They are not in plain text, so the messages are encrypted. It's fully end-to-end messaging system. So messages are only decrypted here on the client side, so not even in my backend. So now we can log out, and that is it. So in this part of the demo, I will present you my continuous integration and continuous deployment process using Jenkins. So basically, with every new push of my code base from my local machine, Jenkins will start the pipeline. So the pipeline will test and build and deploy the application into my Kubernetes cluster. So in order to test that together, as you can see here, the background of my landing page is blue. So we're going to change it to black, and we push this change, and then we will see how this application will be deployed to the cluster continuously. So let's start by changing the background here to black. Let's stage the change, commit the change, color to black. So before pushing the code, let's see here my Jenkins dashboard. So in my Jenkins dashboard, the moment that we push the code here, we should see build started here. So get push. Now we push it. Yeah, here it is. Now, as you can see, the build being triggered here by Jenkins. Now, let's watch together all the stages that running on this pipeline. Here we check the code style, and here we analyze the code using SonarQube. It is here. And here we check for quality gate, also from SonarQube, from here. This one. So we will watch the change in direct together. So here we will watch the change that happened in my running cluster. So now we are building Docker image, and here we are uploading the Docker image to Elastic Container Registry. And watch now here to see for a change before deployment. So watch for a change here. We are in the deployment stage here, and we will see the change happening in my cluster. Yes, here it is. Container creating and container running. And now the new version of my application being deployed to my Kubernetes cluster. Now it's time to test and to see the new version that we change it to black background here. We need to wait for some time. And now let's refresh to see the new version of the application. Here we are. As you can see, the latest version of this application being deployed to the Kubernetes cluster. Now it's online and I can access it. So even I can log to my account. And here we are. So it's working fine. So I'm really happy with these tools and with my pipeline. So in this part of the demo, I will present you how the backend of this application has been tested. So the backend of this application has been tested from unit test to integration test to end-to-end test. So has been tested locally and before every deploy in Jenkins pipeline. So let's test it locally and see the pipeline on Jenkins after that. So for this, npm run test. This is a unit test. Passed with success. The integration test with success, and now finally end-to-end test. So the test basically ensure me that the different components of my application are working correctly and just fine before deploying the application. And here, if you go in Jenkins for the backend pipeline, you can see this is my backend pipeline. So here we create a database, and then we run test on it. We build the application, we run unit test, we run end-to-end test, integration test, test coverage, analyze the code using SonarQube, and archive the code, build the image, and deploy the application to the cluster. So that is it. So in this part of the demo, I will present you my monitoring system that I set up for monitor the health of my application. So my monitoring system is combined of Prometheus for gathering metrics across my cluster and Grafana to nicely presenting them. So let's start by Prometheus front end. So here in Prometheus front end, I can explore all the metrics that have been gathered from my cluster by Prometheus, and I can also query and visualize them. So for example, node load here, I can visualize the data. So this information tells me the CPU average load for the last minute by node, for example, for this node, and also here for this node. But Prometheus is not very rich in terms of visualizing metrics. So for that, I am using Grafana. So here in Grafana dashboard, I can see there are many dashboards that allows me to visualize metrics that coming from Prometheus. So for example, here for use method by node, I can visualize or read the CPU utilization and the CPU saturation by node, and memory utilization, memory saturation by node, network utilization, network saturation by node, disk utilization, saturation by node, and disk space by node. And this data are the same data that were presented here in Prometheus, but as you can see in Grafana, it's much better. And here also the same data presented in a different way. So it's very nice tool, allows me to visualize and read clear information about the health of my cluster and taking decisions based on this. So in this part of the demo, I will present you my logging system that I set up for this application. So my logging system is combined of Fluentd for collecting logs across all the nodes that are running in my cluster, and Elasticsearch to index and store the logs, and Kibana to nicely and easily visualize all the logs. So let's start by bringing up Kibana front end. So before that, I would like to highlight that I have 6 nodes running in my cluster. So I must have also 6 Fluentd pods running in my cluster, each one of them running inside one and only one node running inside my cluster in order to collect logs that inside that given node. So here, kubectl get nodes. As you can see, I have 6 nodes. So let's confirm that I have 6 Fluentd pod as well. So as you can see, I have 6 Fluentd pods, each one of them running in one and only one node in my cluster here. And now let's bring up my Kibana front end. Now, as you can see, my Kibana my Kubernetes service is attached to load balancers. So for that, I can use this external IP. So no worries, I will delete all that after the demo. So now here I am inside Kibana front end. So here in my discover page, you can see how nice and easily I can search for logs. So let's search for errors across all the logs, or error. So I can see errors coming from my application for the last 15 minutes, and I can change it for the last 7 days or 7 days, and I can see I have more than, I have all these logs that containing error. And also I can search for Nest, let's say Nest. This will give me logs that are coming from my server logs. Even I can search by word, just simply successfully. As you can see, that shows me it's very easy, and it makes things very easy to search and visualize logs. Also allows me to create some sort of dashboard where I can visualize logs by, for example, namespace, or even by pod lifecycle, like this. So it's really nice tools, allows me to visualize logs easily. So in this part of the demo, I will present you my alert system that I set up for this application to stay informed about the health of my cluster or my application. So this alert system works alongside Prometheus. So here in Prometheus front end, if I click on alerts link, this will bring me all the alerts that predefined by the stack. So as you can see, all of them, they are in active mode and in green, but watchdog, it means to be in red and firing in order to tell me that my alert system working just fine. So for now, if I want to test if my alert system work just fine whenever there an event happen inside my cluster, match a condition pre-configured in one of these alerts, the alert will be fired. So let's do something in my cluster and watch the change here in my alert system. So here, for example, I created a bad pod. So if we apply this bad pod, should trigger an alert. So here, let's apply it. Now we apply it, and if we try to get the pod, as you can see, we see this message. So now let's go to my alert dashboard to see if really this event been triggered here. So refresh the page, and as you can see, yeah, here it is. So we have this 3 pending responding to the fact that we have just applied something doesn't work here. So yeah, here it is. As you can see, this event match exactly a condition being pre-configured here. So once there an event match a condition pre-configured in my alert system, the alert will be fired, and I will receive after that a message, even through SMS or email or Slack. For now, and I'm using Slack channel to receive alerts. So now here I can receive a direct alert all the time. This now, as you can see, this is watchdog alerts to tell me that it is normal alerts, just to inform me that every single thing works just fine. So with all that said, I can confirm you that my alert system is working just fine to keep me informed about the health of my application. And now let's delete this deployment. And now if we get the pod, we see every single thing working just fine. So that is it for my alert system. That is the end of the demo. So I have walked you through the mission statement of the application, the key process, and system file overview. It was a pleasure to share this experience with you. and I will be more than happy to connect, receive feedback, or even collaborate on future projects. Till then, take care.